Hello, my name is Elena Molina and this is our paper Effect of Color Palettes in Heatmaps Perception, a study. Heatmaps are a very popular technique used to show data distributions. Normally, they encode 3 variables, 2 on the axis and the third one encoded in a color code in each coordinate, typically with a square or rectangular cell. However, over the years, this codification has been varied, and different versions have been introduced. They also exist with non-square cells, such as hex plots with hexagonal cells, or also in combination with maps, as in the image. Bertin called them reorderable matrices. Sometimes changing the order of the axis allows us to discover patterns in the data that would otherwise be hidden. However, there are cases in which this process cannot be carried out, because the axes have a fixed order as in the temporary axis in the calendar heatmaps. Since they are a widely used technique, it is necessary to develop a method that allows us to answer the question, how should we present data in a heatmap? There are many variables that can alter perception. Some of them are the cell size, the number of variables in each axis, the shape of the cell, or the color used. Nowadays, we need more perceptual studies that give us some guidance on how to answer this question. If we focus on the general use of palettes, we find that there are widely used practices that are not convenient, such as the use of non-suitable palettes for colorblind people. Furthermore, some studies show results that can be contradictory, recommending or rejecting the same palette may be due to the different tasks being analyzed. There are some studies combining the analysis of heatmaps and palettes, but they focus on different tasks than the one being analyzed here, or do not use palettes as a changing parameter. Therefore, there is still a lot to know about how people perceive values or trends when using these charts. Of all the variables that could affect their perception, we decided to start analyzing the palettes. So, our goal was to analyze how people carry out some of the most typical tasks using heatmaps, such as estimating values, searching for a certain value, or finding clusters. For this paper, we only present the results of one part of the study, without the clusters. In the following, we are going to describe how we designed the experiment and the charts. The first thing to do was the creation of the stimuli, and we wanted to make them similar to what designers are using in real life. Thus, we first asked ourselves how the charts were currently used, both in the academic environment and also in a more non-specialized setup. So first, we analyzed the papers from 2019 and 2020 of Eurovis and Ievis that had heatmaps. Then, we proceeded to perform a search on Google Images, and we kept with the first 122 results. We found a wide variety of configuration, as well as non-suitable practices. You can see a summary of the collected information in the table on the left. With these results, and in order to ensure that our charts fitted on any screen, we analyzed several cell sizes and layouts, and we decided to keep a total size of around 500 pixels. We created charts with 30 by 30 square cells of 13 by 13 pixels each. The chosen palettes were Viridis as a multi-hue palette, and blues as a single hue one, both as continuous and discrete. Both palettes are really common, but they also stand out in previous experiments. To make the data more relatable, we told the users that we were representing information from a bicycle sharing system, with the number of available bicycles per docking station on the y-axis, per day of the month on the x-axis. Despite this, we later saw that participants tended to ignore the meaning of the axis and just focused on the tasks. So, as previously commented, we wanted to check with these configurations which palettes were more effective for the tasks of estimating the value of a marked cell and selecting a cell with a given value. In both cases, we believed that the best ones would be continuous, since they encode more values, and multi-hue, because they combine color hue and luminance to encode values. Therefore, these were our hypotheses. The first one, when estimating values, continuous palette would be better than discrete ones. The second one, multi-hue palettes would be better than single hue palettes for the same task. The third one, continuous palettes would be better than discrete ones when searching for a given value. And the last one, multi-hue palettes would be better than single-hue palettes when searching for a given value. These are some examples of the charts created. For the first task, we needed to mark a cell and we decided to use a red circle. This combination of colors was checked to be safe for colorblind people using the Color Brewer website. We designed a user study to test our hypothesis with the following steps. First, an explanation of the objectives and what heatmaps are. Then, a demographic survey and the training tasks, where users had to solve the tasks for 3 heatmaps. After this, the actual tasks with 34 heatmaps, and lastly, a questionnaire to evaluate understanding and satisfaction. All marked steps were used to clean the participants. The non-suitable ones, as with poor eyesight, if they were clicking through, check with duplicated tests, and those who showed carelessness or not understanding, making too large error, meaning having an average error of more than 20 when the scale of the data was from 1 to 50. This is an example of one heatmap in the training tasks. Users had to select the answer among some given options. This is an example of how the tasks were presented to the user. In this case, they had to introduce the number by themselves. They could show or hide the circle with the buttons below if they wanted. We obtained 50 participants through Prolific and 53 through social networks. After cleaning, we got 85 participants, 40 females, and 0 of them were colorblind. 79 participants declared that they understood the experiment. 61 were satisfied with their performance, but 24 found the task not easy. To extend our analysis, we decided to investigate the effect of the ranges in the palettes. Thus, we defined the following ranges: small from 0 to 16, medium from 17 to 33, and large from 34 to 50. With this, for each task, we analyzed the differences in errors for same palette, different ranges, and same range, different palettes. This is how we are going to report the results of our repeated measures and of analysis. Top left icon indicates which palettes were significantly better than the others. Bottom left icon indicates that the results are in line with our hypothesis. Top right icon indicates that there were no significant differences, and bottom right icon indicates that the results are contrary to our hypothesis. We will also show the p-values on the images. When we asked participants to estimate the value of a marked cell, we saw significant differences between discrete and continuous palettes and between Viridis and blues, being the first ones the best ones. When we compared the 4 palettes individually, the best one with significant differences was Viridis continuous, not being the expected one with the previous results, which would be Viridis discrete. Following this, when we divided by ranges, the best palettes were Viridis continuous and then blues discrete. Within each palette, the only one that showed differences was blues discrete, giving the best results in the small range. This was contrary to what we expected, that the lightest colors of the blues palette would be worse distinguished. So for the first task, we hypothesized that the best palettes would be continuous and multi-hue, but when comparing them 2 versus 2, this supposition was not fulfilled with the continuous one. However, individually, the best one was the one we expected, Viridis continuous. These results encourage us to explore more the effect of this combination, multi-hue with continuous. When we asked participants to select a cell with a given value by clicking on it, we saw significant differences between continuous and discrete palettes, being the first one the best one. But there was no significant differences between blues and Viridis. When we compared them individually, there was no differences either. When we divided by ranges, we only saw differences in the medium range between blues continuous and the others, being it the best one. Within each palette, All of them show differences based on the range. For most of them, the best range was medium, maybe because it is the range where there is more changes in the color, from light to dark or from blue to yellow. So, for the second task, we hypothesized that the best palettes would also be continuous and multi-hue. When comparing them 2 versus 2, it was only confirmed for the continuous one. Individually, none was better. It may be important to remember that in this task, the participants had more freedom by not having the cell to be evaluated restricted, so they could choose a cell with which they felt safer to give an answer. Finally, when we looked at our data, we asked ourselves if there were any differences in time per task. Sadly, we only had the time measured per palette, because we saved the time spent in each heat map for all the tasks together. So we performed the ANOVA analysis and we saw that there were not significant differences. This would be an interesting study to carry out in a more controlled situation where we could ensure that the user did not lose time between tasks. However, for this study, it was not possible, and it remains as a task for the future. So, for the future, we want to analyze the effect of time per task, if there is a relationship between time and error, maybe check other tasks such as counting clusters, or extend the analysis to other parameters, for example, cell size, or even to other common palettes, like magma or with orange colors. Finally, with all this, although there is still a lot of work to do, our recommendation would be to use Viridis Continuous, since it was the best one in the first task and not dominated in the second one. Thank you for your time and your attention.